Assalamu alaikum and good day. So in this video we will discuss the answers on the Tom Schriber problem. So these are the activity days. So there are 3 time estimates. So we will be using PERT analysis. Okay, so these are our immediate predecessors. Okay, so there are 12 activities and maximum 3 predecessors and 3 time estimates. So our formula, we will get the expected time. So these are the requirements: network, determine the expected time and variance, determine the early start, early finish, late start, late finish, and the slack, determine the critical path and project completion time, determine the probability that this project will be completed in 70 days or less, and in 80 days or less, and in 90 days or less. So this is our precedence chart for this problem. So as you can see, from start, we can either do A, B, and C. There's no immediate predecessors. We can start from either each of them, and the last activity will be K. So using the formula for expected time, A plus 4m plus B divided by 6, we will get for activity A, 8 plus 4 times 10 plus 12 all over 6, we will get 10. Okay, and you can do the same for B, C, D, and so on. Okay, so for variance, the formula is B minus A. So B is the optimistic and A is the B is the pessimistic and A is the optimistic. So divided by 6, then squared. So we have here, our B here is 12 minus 8 divided by 6, then squared. So we will have 0.444, and you can do the same for the next of the activities. Okay, so by doing the forward pass, we can get the earliest start and the earliest finish. Okay, so for example, for activity A, earliest start 0, earliest finish 10. So from 10, dyan na naman mag-start yung immediate successor ni A. Okay, so for example, for activity E, okay, so for activity E, we have activity D, yung immediate predecessor niya is A. So from A, 10, early start niya is 10, plus its expected time is 20, 10 plus 20, 30. So just forward pass on the time. Okay, so for E naman, its immediate predecessor is si C. So yung earliest finish ni C, 3.167, yun yung magiging earliest start niya, 3.167, plus yung expected time niya na 7, it is his its earliest finish of 10.167. Okay, so on and so forth. So sa latest finish naman, magsa-start tayo by doing the backward pass. Okay, so from backward pass, so our end activities are K and L. Okay, so dito, so from K, okay, so 68.67, okay, so less mo yung expected time niya na 2.167, so we will get 66.5. Okay, so the same with activity K, the latest finish is 68.67, less yung 6.67 expected time niya, its latest start is 62. So again, these two will be determined using the backward pass. So here, we will get the slack so that we can get the critical path. Always remember that those activities that have zero slack are all the activities on a critical path. Ibig sabihin, wala silang slack. There's no room for delay. So, these are the activities that if they are delayed, they will cause the entire project to be delayed. And they are called the critical path activities. So, we can here the earliest finish EF minus LF 0, so our slack is 0 for A. For B is 22.83, okay, and for C 19.83, D 0. So, ano ba yung mga walang slack natin dito ng activity? F, 0, H, 0, J, 0, K, 0. So, yung critical path natin are A, we have D, F, H, J, and K. Okay, so this is how our PERT, PERT Gantt chart would look like. Okay, so yung red colored are those critical activities, and we have this blue for the slack activities. Okay, so yung may mga slack, yan yung pwede pa nating i-crash if we will permit crashing, no? Okay, so yan yung PERT Gantt chart natin. So yung critical path natin are again A, D, F, H, J, K. So, para makuha natin yung project completion time, kukunin natin yung variances of the activities in our critical path. So, ito yung magiging result. So, we have the 12.33. Okay, so tandaan mo na yung project variance natin na 12.33. Okay, so next, we determine the critical path and the project completion time. So, again, kanina, when we determine our project variance, we can use that to get our project standard deviation. So our project standard deviation is just the square root of our project variance. So the square root of 12.33 is 3.51. Okay, so 3.51. Okay, so yung standard normal equation natin is from due date less the expected date of completion natin that we have computed earlier, divided by our project standard deviation, the T. Okay, so again, we have determined here that our project is 68.67 days, and we have our project variance 12.33, and our project standard deviation of 3.51. Okay, so next we will determine the probability that the project will be finished in 70 days or less. Okay, so again, 70 days less our estimated completion of 68.67 divided by 3.51. So we get 0.378. So at this point, please do not round off, no? Okay, para dito na tayo mag-round off sa final answer. Okay, so our probability, so hanapin lang natin ito under the standard normal area, okay, sa table. So the probability that this will be completed on or before 70 days is 64.7286 or 64.73%. Okay, so take note that 0.378 is between this area. Okay, so 0.64431 and 64803. So if you want accurate result, we will interpolate, no? Kasi nasa gitna siya. So we interpolate and we will get 64.73%. To be exact, precise, and accurate. No? So please do not round off in this point, but round off on the final answer. Okay, so determine that the probability that the project will be finished in 80 days or less. So again, our formula, 80 days less the estimated completion of 68.67 divided by 3.51, we will get 3.227. Be it noted that 3.227 is between here, 3.23 and 3.22 and 3.23. So we get 99.94% exactly as we interpolate. Okay, so probability 90 days or less, so 90 minus 68.67 divided by 3.51, 6.076. So, under the table, this is already 100%. Kasi kanina nga na 80 days is 99 something na. So, pag matapos daw siya in 90 days, that's definitely 100% sure na matatapos yung project within 90 days. So, these are the discussions and the answers of the Tom Schriber problem on PERT analysis under project management. Okay, so more learning on the next topic.